Hi everybody, and welcome to exercise 1 on page 36 of the workbook. And this is going to be our first example of actually doing a calculation with a differential. Okay, we talked a minute ago about how differentials are about approximating the change in a function. Okay, part 1 is strictly computational here. Part A of number 1. They're just asking us to calculate the differential of g of uv equals u squared plus uv. And if we sneak a peek back at the formula for the differential, okay, back up here, finding a differential is really about finding derivatives. That's going to be our starting point when we do this. All right, so let's first take our function and calculate the partial derivatives with respect to u and v. So what is the direction or the derivative of our function with respect to u? Well, we'll be looking at this formula, treating our u's as variables and our v's as constants. So when we take the derivative of u squared, we're going to get 2u. And then the derivative of uv, we are treating the v as a constant. So we'll take the derivative of u and get 1, and the v is just going to come along for the ride. So g, the derivative with respect to u, is 2u plus v. Okay, what about the derivative with respect to v? Okay, well, to take this derivative, we're treating u as a constant, and so that means this first term u squared, that's just got constants in it, and so when we take its derivative with respect to v, it's just going to go away. It's going to become 0. Okay, and then the second term, we're treating the u as a constant again. Okay, take the derivative of the v, you're going to get 1, and so what's left over is just u when we take that derivative. Okay, so what that means then is that we're ready to write down the formula for dg, the differential. Okay, and if we write out that formula, it looks like the partial derivative with respect to u times du plus the partial derivative with respect to v times dv. Okay, so all that's left to do here then is to just fill in the two derivatives that we calculated. They're sitting here and here. And so we're going to get 2u plus v times du, okay, plus u times dv. Okay, and there's our formula for dg. And again, what this represents is just the approximate change that we're going to get in g if we change our input values a little bit. Okay, so with that in mind, let's move on to part B here. So they'd like us to use our answer to part A to estimate the change in g as we move from 1, 2 to 1.2 to 2.1. Okay, so to use this formula for the differential, what it really comes down to is kind of just nailing down what all the variables are. Okay, so our starting point, 1 and 2, those are our u and our v, and then the du and the dv are the amount that those two variables change. Okay, so what would du be? Well, we start at 1 and we move up to 1.2, so we increased our u by 2. That's going to give us a du of 0.2. And what about the v? How much did it change? Okay, well, we started at 2 and we ended at 2.1, so that's going to go up by 0.1. All right, and so to get the approximate change in g, we're going to calculate dg, and that's just a matter of going back and just filling in the pieces in this formula. We know what u and v are. They're 1 and 2, so we'll fill those in. Okay, we now know that du is 0.2. Okay, and let's see, then we come to u dv, and we know that u is 1, and that dv is 0.1. Okay, and the rest is just arithmetic, figuring out what this is. So we are going to get, let's see, for the first term, 4 times 0.2, that's going to give us a 0.8 plus 0.1. Add those together, and we get 0.9. Okay, there's our answer, and again, that just represents the approximate amount that g is going to change if we move between these 2 points. Okay, and we are done with the problem.